see the screen? Share. Ayomide, can you see my screen? Please respond.
Yes.
Good. These are just dumb questions. It will be like alternate. Like I told you, I'll alternate it. Today I'll take the jump content. The next week I'll take the wire content. So what I have here, if you can see the screen, is physics past question for 2023. That's the last year's question. Okay. So I want to begin with. I want to focus more on the calculation questions, but then nothing wrong in us looking at the other aspects. Okay, now look at question 1 very well. Question 1. What is happening there? This is a wave. You can see my cursor. This is a wave. Okay, moving towards an obstacle. So because the obstacle is having a gap, the wave spreads out through the obstacle. Okay. Now, this, what do you call this phenomenon? Have you seen it? Have you seen this before? You can send me a chat if you can't. You can send me a chat if you can't.
Sir, I'm sorry. Can you recap?
Okay, I said this diagram is showing us a wave approaching an obstacle. Just look at my cursor. This is my cursor. This is a wave approaching an obstacle. Then the obstacle is having an opening. It has an opening. Sir. Good. So what will happen is that beyond the obstacle, the wave will spread out in this fashion. See, do you know what is happening here?
Yes.
Okay, what is it?
Because the opening space is small, is very small.
No, yes, yeah, you can't really say it's small, but what property of wave is this? Property of wave is this? You know, wave has properties. Reflection, yes. Refraction, interference, diffraction. So which one is this one?
Interference.
This one is diffraction. Now, write it down.
Diffraction.
Write it down in your notes. Yes, this is diffraction. Take down the definition of refraction now.
Okay, sir.
Take it down. D-I-F-F-R-A-C-T-I-O-N.
Apprentice.
Okay, now diffraction is the spreading out of a wave. Diffraction is the spreading out of a wave.
Okay.
As through the openings of an obstacle. Through the openings of an obstacle. The spreading out of a wave through the openings of an obstacle. Now, there's something I want you to also know, that if we make this gap opening, if we make it smaller, this diffraction will be stronger.
Okay.
Or if we increase the gap, the diffraction will be weaker.
It'll be weaker.
Okay. I said if this gap is made smaller,
okay,
the diffraction will be stronger in nature.
Okay.
The diffraction is higher, but if I make it bigger, the diffraction effect will be weaker. So write it down. If the opening is smaller, diffraction is stronger. If the opening is smaller, yes. If the opening is smaller, diffraction is stronger. If the opening is smaller, diffraction is stronger, and vice versa. That is, if the opening is bigger, the diffraction is bigger.
Sir. The first one, if the opening is smaller, the diffraction is stronger.
Fantastic. Then this is the opposite now. If the opening is bigger,
sir, wait. If the opening is smaller, the diffraction will be stronger.
Yes.
Okay.
Is bigger, diffraction is weaker. It's just opposite. What an opposite? Eh?
If the opening is bigger, the diffraction will weaker.
Will be
okay,
weaker.
will be
Yes.
weak.
Will be weaker.
Oh, thanks.
All right. So let's move on to the next question now. The next question is talking about, that's number 2. It's talking about the application of electrical conduction in gases. It's talking about the application
of
electrical conduction in gases. So now they're asking us, what is the application? It has application in lighting and fluorescent tube. Okay.
Is that
application in lighting? Yes. Yes, it has application in lighting. This one is number 2 II. Can you see number 2 II?
Sir, can you help me to board it?
To do what?
To board it.
Okay, I'll do that. Is it okay now?
Yes.
So number 2, the one application of conduction in gases is lighting and fluorescent tubes. Lighting and fluorescent tubes.
Lighting. Sir.
Yes.
Lighting and what?
Just check 2 II. 2 II. Can you see 2 II?
Yes.
So I think it has application in II, and IV. That is, it's used to identify gases. Used in fluorescent tubes. It's also used in cathode ray tubes and TV screen, TV tubes.
Is that what?
Just copy II and IV. Copy, just copy it down in your notes.
Both.
No, copy II and IV.
Okay.
Copy it down. They are the uses of they are the applications of conduction in gases.
Okay, sir. Done.
Okay. Let's move on to question 3 now. This question 3 wants us to find the tension. This is a load hanging suspended using 2 ropes. One rope is tied to the wall, another rope is tied to the ceiling, as you can see now.
Okay.
Now, so this one here, I think I'll need to solve it on the board for you. This one, the weight, there are 3 forces here: weight, tension 1, and tension 2. So you want us to find the 2 tensions. For you to solve this one now, you need to make a rectangle triangle. Now that's in which the sides are the three forces. The three forces will represent the sides of the triangle. Let me show you now. Let me show, I'll show you. Let me solve it on the board for you. You can see my board now.
Yes.
So I can have something like this. Anytime you see an arrangement like this, okay, you can make it up into a right angle triangle. This is T1, but this one is slanted, this one is horizontal, that's T2. And this is the weight. The weight of the mass is 200 Newton. 200 Newton. 200 Newton. Yes.
Yeah. Can you recap?
Can you see?
I'm seeing your board.
Now that's fine. That's good.
Yeah.
So me to the angle here. This angle is this is 38 degrees. 38 degrees.
38 degrees.
Yes, but let me see.
Because
okay.
You said
yes, this is theta, 38 degrees. So now with this, now we are going to now find our T1 and T2 using SOHCAHTOA.
Yes.
SOHCAHTOA. So if I use sine now, all I have sine theta, sine 38 is equal to what?
Sine 38.
Opposite
over sinus.
So if I continue to solve it now, I'll have T1 once multiply 2200 over sine 38. So if you have a calculator there, you can press it. Let's see what the answer is. Press the
calculator, sir.
Don't worry. You can just write it. Maybe later on, if you see calculator, you just use it to do it.
Okay, sir.
Just write it down. Write down what's on the board.
What do you write on the one face the SOHCAHTOA? The one face the theta. That opposite one. What did you write there?
2200 Newton. This one here, 2200 is the value.
Okay, sir. Okay, sir.
So with that one,
I will do it.
Then the other one, T2 is cos 38, which is adjacent. Okay, we can even use tan if you like. Tan 38 is opposite over
adjacent.
So T2 now will give me 2200 over tan 38.
Okay, sir.
So later on you do it.
Okay, sir.
Let's move on. Let's proceed to the next question.
Okay, sir.
That's number 4. Number 4 is talking about projectile. Projectile. For projectile, this is how it looks like. Velocity time graph. If you project an object like this at a particular angle to the horizontal to follow a parabola, while it moves, it follows a parabola until it strikes the ground. So it follows a parabolic path from where it is projected, okay, until it lands on some distance away from where it is projected. So now the height from here to here is the maximum height. Because the height keeps changing. Yes, maximum height. Then this is the range. So
that maximum from that maximum height to the end is the range.
Yes.
Why? Sorry, sir.
No. Range is what? Range is from here, from the point of projection to where it lands. See now, from the point of projection
to the where
it
it
lands.
Okay.
Yes. So the question that they're asking us to find the range, horizontal range, which is R. The formula is U squared sine 2 theta over G. So
R is equal to what?
U squared sine 2 theta. Can you see my board very well?
Sorry, sir. R is equal to what? Is that U square?
U squared sine 2 theta over G.
Sine theta over
U squared sine. Is that? Yes. That's the formula for range. Now
okay, sir.
you now
Okay, sir.
have to substitute the values. You have all the values. Your U is 75. From the question, you can ask, if you can see the question on the board, on the screen. U is 75.
Yes.
Theta is 22. And of course, G is always 10. It's even there. So R is equal to 75 squared sine 2 times 22 over 10. 75 squared sine 44 over 10. So can someone help us compute it? Press the calculator and get the answer. If you have got the answer, let me know. If you have got the answer, let me know. If you don't have a calculator, we can move on.
Let's move on. We'll give you feedback later when we are done with it.
Later on, you can work it out later.
Yes. So let's move on.
Okay, let's proceed now to question 5. Question 5. Question 5 is talking about relative humidity. Relative humidity. Now, the formula for relative humidity is pressure of air, pressure of water vapor in air over pressure before saturation and pressure at saturation. Relative humidity is pressure of air before saturation and pressure of air at saturation. Before saturation and pressure of air at saturation times 100 over 1. It's always in percentage. So let us work it out now. What is the pressure of air at saturation? They give us is at 40 degrees Celsius. The table there is those values on the table are pressures at different temperatures. Okay, for which the atmosphere is saturated with water vapor. So at 40 degrees Celsius, the pressure there is 55.3. While the pressure at before saturation is 38.8. So if we substitute that, it will give us 38.8 over 55.3 times 100 over 1. So if you work out this later on, much later, you'll be able to get the answer. Is that okay?
Yes.
Okay. Let's move on to next question now. Okay. Now we're looking for, question 6 is talking about absolute pressure at the base of a lake, which is 32.8 meters deep. Density of water 1 times 10 to the -3 kg per meter cube. No, it's supposed to be, no, it's not correct. It's supposed to be 1 times 10 to the ⁵. So there's a mistake in the figure. It's supposed to be 1 times. Okay, why this is external pressure. So anytime you're looking for pressure in a liquid, the formula is like this. Pressure.
Sorry, sir, you have 10 more minutes to go.
Yes. Okay. Rho GH plus PO. This is the formula for pressure in the liquid. This is external pressure. This is pressure to depth. We can call it the gauge pressure. And this is the actual pressure. Actual pressure, gauge pressure, external pressure. So let's substitute now. We're looking for the absolute pressure or the actual pressure, which is this. So we have now we substitute. Our density is 1 times 10 to the ⁵. Our G is 10. The value of height or depth, sorry, 32.8. The external pressure is 1.103. 101, sorry, 101.3 times 10 to the ⁵. So if you take your time and solve this, you get your answer. If you take your time and solve this, you get your answer. Yes. All right. Can leave your answer in kilopascal. You can leave your answer in kilopascal. Hope is clear.
Yes, sir.
Okay. Okay. Question 7 now. We'll solve like 2 more questions. I think we can call it today.
Let me hear what.
Now, the terminals of a battery of EMF 240, 24 volt, and internal resistance.
That was small r.
Yes, small r.
Ohms.
The external resistance, big R, 5. Find the
Yes.
terminal PD. Okay, good. Now, for EMF, for cell voltage, you have
No.
which is nominal voltage plus terminal voltage loss voltage. All right. So if you have a cell like this, supplying current to external circuit. If the cell has a small r, it will lose voltage upon delivery of current. So now the loss voltage, if you add it to the terminal voltage, to give you the total voltage of the cell. So in this question, they want to find this terminal voltage. Okay, why this? Another for nominal voltage is EMF. Is EMF. So they are supposed to give us current. There's no current in the question. They're supposed to give us current. You can't solve this because you don't have current. Okay, we can find the current. Then we now use to find the terminal voltage. Okay, that's good. So we have EMF is equal to I into R plus R. So when I now find the current, I'll now use the current to find the terminal voltage. The terminal voltage is equal to I times big R. Okay, so let's find the nominal voltage now. So nominal voltage will be, this is 24 is equal to I. No, we're looking for current, sorry. If we want to now find the current, we now use it to find our terminal voltage. So 5 plus 1, which is 6, that'll give us 24, is equal to 6I. I is 4 amperes. So I is 4 amperes now. 4 amperes. So now I can now find my terminal voltage, and now say terminal voltage is equal to 4 times 5. That's 20 volts. Can you see now? So
yes, sir.
So with that current, you go to find terminal voltage. Okay, I think this can be our last question, so we don't encroach into something else. So the last question, a lorry, number 8 is the last question for the night. The lorry has uniformly in a straight line with acceleration of 4 meters per second. The lorry accelerates uniformly in a straight line with acceleration of 4 meters per second squared and covers a distance of 250 meters in 10 seconds. How far will it travel in the next 10 seconds? So that means, which means this one now is not okay. It said covers a distance of what, 250 meters in 10 seconds. How far will it travel in the next 10 seconds? So we are after the how far to travel in the next 10 seconds. So you can solve it in 2 ways. You can solve it using graph. You can also solve it ordinarily. Now, for this very question, we're going to use S is equal to, we're looking for distance. We have acceleration. Acceleration is given to us 4. Then time is 10 seconds.
Time.
Yes, 10 seconds.
Time 60.
60. No. Now we are going to with this information here, we can find the initial velocity, which we'll now use again with the same formula. Our formula is S is equal to UT plus half
AT squared.
Fantastic. So this one now, with this formula here, we're going to find U. But we don't know the U. Without the U, we cannot find the distance covered in the next 10 seconds. So let's go ahead and find the U now. We say 250 is equal to U times what, 10 plus half times 4 times 10 squared. 250 is equal to 10U plus 2 times plus 200. 10U is equal to 50. Then U is equal to 5. So with this U now, we'll now use the formula again to find distance cost. So we're using the formula again. S is equal to UT plus half AT squared. So this time around, we say 5 times 10 plus 5 times 4 times 10 squared. So, okay, it's looking like it will give you the same 250. So it will still give you that 250. It's still 250 meters. Yes. If you work it out, to give you 250 meters. And the answer is that's option D. So we can't go any further. So I don't encroach into the time. So I think that's all for today. Next time we're going to take something else.
Thank you, sir.
All right, you're welcome. All the best.